This tutorial will illustrate how a moving vehicle can dynamically excite a bridge. We will run an HS-20-44 truck at 3 different speeds to see the different responses. Our composite bridge has 2 spans, each with a length of 100 feet. It is 36 feet wide, constructed with steel girders, cross-brace diaphragms, and a concrete deck. It has 2 12-foot lanes, but we will only load lane 1. We start by going to the Loads tab to define our truck. When using a vehicle load for a dynamic analysis, it is important to use a truck load and not a lane load. We next add our vehicle to a vehicle class. Next, we will define our bridge load pattern. We will call the pattern truck with a type of bridge live. Clicking on the Modify Bridge Live Load button allows us to specify how the trucks will run over the bridge. Here we can specify the vehicle, the lane, the start time, and the speed. For the first truck, the start time will be 0, and the speed will be 75 feet per second. For the second truck, the start time will be 6 seconds, and the speed will double to 150 feet per second. For the third and last truck, the start time will be 11 seconds with a speed of 300 feet per second. We are using speeds considerably higher than typical to cause a significant excitation of the bridge. We will use a 15-second duration for the load and a step size of 0.05 seconds. The last step is to modify the truck load case from a static moving load case to a time history case in order to capture the dynamic effects. Moving to the Analysis tab, we select the truck case and click the Modify button. Note that the case for the truck load pattern was created with a type of multi-step static. We will change this to a time history analysis to include dynamic behavior. We will leave it as a linear analysis, but will change to direct integration. The program automatically creates a default load application using a ramp function to apply the truck loads, which we will not change. We will ask for 320 time steps, again at a step size of 0.05 seconds. We are now ready to run the analysis. Note that the truck load case is now a dynamic case. We will shut off the dead and modal cases as we do not need these. With the analysis complete, we can display the deformed shape. In this case, we will show the shape at 1/2 second into the analysis. However, the dynamic effects of the vehicle loading can best be seen by creating a movie. Here, we will create a movie for the truck load case. We will increase the magnification to make it easier to see, and make sure that the Show Vehicles option is checked. When we play the movie, we see that the first truck has a limited dynamic effect on the bridge. And the second truck slightly more. However, the third truck causes significant excitation of the first mode of the bridge. Once again, the first truck at 75 feet per second. The second truck at 150 feet per second. And the third at 300 feet per second. In conclusion, bridge structures may be sensitive to the dynamic effects imparted by moving vehicles, and CSiBridge offers a powerful and easy way to include and view these behaviors. This ends this tutorial on dynamic vehicle loads.